Top 5 Facts about Pluto. 5 years ago today, NASA's New Horizons spacecraft made history. After a voyage of nearly 10 years and more than 3 billion miles, the intrepid piano-sized probe flew within 7,800 miles of Pluto. For the first time ever, we saw the surface of this distant world in spectacular, colored detail. The encounter, which also included a detailed look at the largest of Pluto's 5 moons, Charon, capped the initial reconnaissance of the planet started by NASA's Mariner 2 more than 50 years before, and revealed an icy world replete in magnificent landscapes and geology, towering mountains, giant ice sheets, pits, scarps, valleys and terrains seen nowhere else in the solar system. 1. Pluto has a heart, and it drives activity on the planet. Sometimes you just have to follow your heart, and Pluto seems to have taken that advice quite literally. Pluto's heart, one of the signature features New Horizons observed on approach and imaged in high resolution during the flyby, is a vast, million-square-mile nitrogen glacier. The heart's left ventricle, called Sputnik Planitia, literally forced the dwarf planet to reorient itself so the basin now faces almost squarely opposite Pluto's moon Charon. Sputnik Planetia's current position is no accident. It's a cold trap, where nitrogen ices have accumulated to make an ice sheet that's at least 2.5 miles, 4 kilometers, thick. The constant imbalance of that hefty mass, combined with the tidal yanks and pulls of Charon as it orbited Pluto, literally tipped the dwarf planet so the basin aligned more closely with the tidal axis between Pluto and Charon. 2. There's probably a vast, liquid, water ocean sloshing beneath Pluto's surface. Gathered ices may not be the only thing that helped reorient Sputnik Planitia. New Horizons data from the basin indicated there may be a heavier mass beneath it that played a part, and scientists suspect that the heavier mass is a water ocean. Sputnik Planitia was likely created some 4 billion years ago by the impact of a Kuiper belt object 30 to 60 miles, 50 to 100 kilometers, across that carved out a massive chunk of Pluto's icy crust and left only a thin, weak layer at the basin's floor. A subsurface ocean likely intruded the basin from below by pushing up against the weakened crust, and later the thick of nitrogen ice seen there now was laid on top. 3. Pluto may still be tectonically active because that liquid ocean is still liquid. Enormous faults stretch for hundreds of miles and cut roughly 2.5 miles into the icy crust covering Pluto's surface. One of the only ways scientists reason Pluto got those fissures, though, is by the gradual freezing of an ocean beneath its surface. Water expands as it freezes, and under an icy crust, that expansion will push and crack the surface, just like an ice cube in your freezer. But if the temperature is low enough and the pressure high enough, water crystals can start to form a more compact crystal configuration and the ice will once again contract. Models using New Horizons data showed Pluto has the conditions for that type of contraction, but it doesn't have any known geologic features that indicate that contraction has occurred. To scientists, that means the subsurface ocean is still in the process of freezing and potentially creating new faults on the surface today. 4. Pluto was, and still may be, volcanically active. But maybe not volcanic in the way you might think. On Earth, molten lava spits, drools, bubbles, and erupts from underwater fissures through volcanoes sitting miles high in and protruding from the oceans, like on Hawaii. But on Pluto, there are numerous indications that a kind of cold, slushy cryolava has poured over the surface at various points. Scientists call that cryovolcanism. Wright Mons and Picard Mons, two large mountains to the south of Sputnik Planitia, each bear a deep central pit that scientists believe are likely to be the mouths of cryovolcanoes unlike any others found in the solar system. To the west of Sputnik sits Viking Terra, with its long fractures and grabens that show evidence of once flowing cryolavas all over the surface there too. 5. Glaciers cut across Pluto's surface even today, and they've done so for billions of years. Pluto joins the ranks of Earth, Mars, and a handful of moons that have actively flowing glaciers. East of Sputnik Planitia are dozens of, mostly, nitrogen ice glaciers that course down from pitted highlands into the basin, carving out valleys as they go. Scientists suspect seasonal and megaseasonal cycles of nitrogen ices that sublimate from ice to vapor, waft around the dwarf planet and then freeze back on the surface are the source of the glacier's ice. But these glaciers are not like our own water ice glaciers here on Earth. For one, any melt within them won't fall toward the bottom of the glacier, it will rise to the top, because liquid nitrogen is less dense than solid nitrogen. As that liquid nitrogen emerges on top of the glacier, it potentially even erupts as jets or geysers. Additionally, there is the fact that some of Pluto's surface is composed of water ice, which is slightly less dense than nitrogen ice. As Pluto's glaciers carve the surface, some of those water ice rocks will rise up through the glacier and float like icebergs. Such icebergs are seen in several New Horizons images of Sputnik Planitia, the largest of Pluto's known glaciers, which stretches more than 620 miles, 1,000 kilometers, across, about the size of Oklahoma and Texas combined.